So when I was starting my grad school in mid 90s, right? I started in 93 actually. You could see that there were a lot of people who were not in core IT areas who are doing a lot of AI. They were actually looking at whatever technology that had been developed by the AI specialists and trying to use them in their own domains. But the core AI research itself had started shrinking. Right. So I was probably the last generation of people who actually worked on neural networks back then. Right. So my master's thesis was on neural networks. Right. So reinforcement learning and neural networks, and kind of died away after that. Right. So by the time I was graduating, if you say that you are working in neural networks, you couldn't find a job. So that's how bad it had become, right? But then what happened was in 2012, right? 2010, 11, 12, around that time, there was a huge revival in neural network research. Right, it's called deep learning now. We know it as deep learning now. So what happened then was that Jeff Hinton, who many of you know because he won a Nobel recently. Ironically, this was not for what he was awarded the Nobel, but he, along with a student of his, right, I can't pronounce his last name. They basically built something called AlexNet, right, which was a multi-layer neural network, if you will, right. And I mean the basic premise behind neural networks is the computation is organized like it happens in the brain, but they came up with this multi-layered neural network which was able to advance the state of computer vision, the level at which the computer programs can recognize objects and images. Right, they were able to improve the state of the art by 15%, which is a huge jump in performance. While people year on year were able to improve by 1 or 2% because a lot of engineering had gone into these systems already, but these people were able to get a 15% improvement in performance with just a very simple, conceptually simple model, but something that required a significant leap in our understanding of how computation works. And so that really caught people's imagination. Within a very short period of time, these deep networks were able to do these object recognition tasks better than humans. Okay, so there's a somewhat ironic thing about quote unquote what we call intelligence, right? So things that we typically think are higher order intelligence, like playing chess, right? Or proving theorems, like doing strategy games and stuff like that. AI was able to crack a decade or so earlier than things that we take for granted, like computer vision, right? So, for example, looking at a picture and saying, okay, is there a man there, or how many dogs are there in the picture, is something that's pretty rudimentary skill, right? Sometimes we don't even think of it as requiring intelligence, right? But these were the kind of tasks which computer scientists and AI researchers were struggling for several decades to get right. Right, so people could I mean, vision and language, right? Trying to understand spoken language and things like that. Even forget about irony and innuendo and other kinds of things. Even straightforward English sentences, trying to parse them and trying to understand the meaning, was actually pretty challenging for computers, right? And so it was a huge revelation to the AI community that vision, which was a hard problem which people had been trying to solve for more than 4 decades, right, had been struggling. And here was this model which didn't use any of the standard engineering tricks that people had built over 4 decades to solve the vision problem and could get better than human performance. Right, so that really, amped up the interest both in the research community as well as the funding community and as well as in the industry. Right, in reviving interest in AI research. Right, so and AI came to be deep learning for a while, right? So that's and you had a lot of these amazing breakthroughs come because of this deep architectures that were now enabled thanks to Hinton's breakthrough and a bunch of other people who followed up and then who came up with better methods to train these models than what Hinton's breakthrough was, right? All the both the Nobel, right? So Hinton's was on training multi-layer network, and then the chemistry Nobel also went to AlphaFold, right, which is a AI method that could discover protein structures, right, and that also was again enabled due to deep learning and of course reinforcement learning to some extent, but largely because of the advances in deep learning.